All right. The big finishing question in a thermochemistry chapter in Gen Chem 1 is a calorimetry question. Now, this is a coffee cup calorimeter. It's at constant pressure. We're going to assume that the density is 1 gram per milliliter for the system. And that way we can calculate the delta H. Now, the delta H is the energy per mole. Don't forget, that's joules or kilojoules per mole. Now, what we don't tell you in Gen Chem 1 that we'll show you in Gen Chem 2 is that at constant pressure, Q equals delta H, that Q is delta H. And so what we need to do in order to figure out delta H is calculate the Q per mole. And so we give you some information. We give you that the sample is 12.8 grams. That's what we're going to use to figure out the number of moles. And we're giving you all of this other information to figure out Q. Now, we have to remember that Q for the system equals negative Q for the surroundings. And we're going to call the surroundings the water in this case. All right, and so let's put it together. Q for the water equals 750 grams. That's the water there. And we're going to do 4.184 joules per gram degree C. The difference in temperature is 29.4 minus 31 degrees C. So when we put that into our calculator, we get that the energy change for the water is negative 5,020.8 joules. All right. Now, what does this mean for the system? It means it's positive 5,020.8 joules. And now we've got our Q. So what's left is to figure out the number of moles that reacted to get that Q. I've got to use the molar mass of potassium chloride to do that. That's 74.5513 grams per mole. And I calculate that I used 0.17169 moles of calcium chloride. And so in order to sort out the delta H of the reaction, I take that energy Q for the system, I divide it by the number of moles, and I get 29,245 joules per mole. And to express it in kilojoules, and the correct sig figs, 29.2 kilojoules per mole. And that's it. That's the last question and the answer for that question.